Hey guys, let's discuss new design in system design, which is called Netflix recommendation system. So earlier video I have created on Netflix system design. So this recommendation system I have also talked about there, but here we will discuss in detail. And this video will be specific to recommendation systems only. Okay, so here is your functional requirement. Okay, so what would be the functional requirement for this? See, this is this recommendation system. Okay, so show personalized recommendation homepage for each user. Now second is recommend similar movies, provide continue watching, show trending content, adapt to user behavior in real time, and handle millions of user concurrently. So the home page we see when we log in Netflix, right? So you know that you can see one section for recommendation similar movies. You have recently watched some movies, so you will see that section there, recommendation movies. And then second, you will see the continue watching blog also, right there. You will when you go to right hand side, you will see all the movies. And then show trending contents also, you will see one block, correct? And then adapt to user behavior in real time. So we will use some ML model to uh, track the user behavior, and then find the recommendation on top of that, and then handle millions of users concurrently. So yeah, this system should have handle this much request. Okay, so for example, if user watch Narcos and Money Heist, okay, so system should recommend Stranger Things and Breaking Bad also, because all these series in the same genre. So now non-functional requirement should be like low latency. Okay, less than 200 millisecond it should take when you click on play, and then the your video will come. Okay, will show. Now or when you click on the home page, the recommendation videos it will show, right? So it should take more than 200 less than 200 millisecond. Now highly scalable, okay, millions of user can use it. Highly available, 99.99%, no downtime. And then real-time personalization and fault tolerance. So now let's talk about the high level architecture here. Okay, so this is users activity. Okay, this is users activity. Then this one is event pipeline. So whatever user do activity like play, pause, stop, or watch movie, okay, all that thing will come into this event pipeline. From here, as a raw data, it will go to it will go to feature, and then we will extract feature from that and store that feature into feature store. And then that feature we will give it to ML model. Okay, it will generate the candidates means recommendation movies and all. Now after that, it will give some ranks to those candidates, and then top result it will show on UI screen. So that's it. Now high level architecture, if we talk about, so the flow will be user watch video, okay, then event captured, feature computed, candidate generated, ranking model sorts, and top result show. So this is the normal flow. For example, if user Rahul watched Narcos and Money Heist, okay, and so system will find the similar users like Rahul, and will retrieve 500 candidates, rank them, and show top 20 to Rahul and his similar users. And then on home page, because you watched Narcos, top picks for you and trending now, these things you will show. So candidate generation, if we talk about, this stage retrieves possible videos. Okay, source similar users, similar videos. Okay, like for example, my kind of user, what movie or series they are watching. So on top of that, it will find what is trending, and then popular in that particular region, continue watching. Okay, so all these things he will send as a candidate. And then the output will be 500 candidate videos, because see, the video which you have already watched, you system wants that you continue that one, right? And there is the highest probability that you will continue, because you have selected that video. So now ranking model, if you talk about, deep learning model ranks candidate. Okay, so input feature, What will be the input for this ranking model? Your watch time, your genre preference, okay, which kind of movie you're watching, and then device type, okay, on mobile or on laptop or on tablet where you're watching that, time of the day, and recent clicks. So model will find probability of user click this video or not. So on top according to that, it will give some score to that particular videos, and then also he will sort it by scope, like top result shown, okay. So top result he will find from that top score videos. Now feature engineering, if you talk about here, so here we will be talking about feature, okay, which we will store in feature store and give it to ML model. So here you have three types of feature: user feature, video feature, and context feature, okay. So in user feature, we will find average watch time of the user, okay, then favorite genre and binge watching score, like what is my binge watching score. So according to that, it will recommend me the videos. And then video feature is video genre, okay, what is the genre, then popularity score, that video's popularity score, and then completion rate, how many people are completing that video. Context feature is the context, like time of the day, okay, device type, location, so all these things. Now if we talk about database table, here we will be talking 7 to 8 database table here. So the first one is user table, okay. So user table will have user ID, name, country, language created. Why we are using it? To identify user, personalize recommendation, and filter by region or language, so that from India we will recommend him Hindi movies, right? So second is video table. So it will have the video information, like video ID, title, genre, duration, release year, language, popularity score. So why we are using this? Metadata for recommendation, okay, genre based filtering, and popularity ranking. So user likes thriller, so filter genre thriller. So we will show him the thriller movies only. So now user watch history, okay. The third one is user watch history. So user watch history will have the what movies user has watched. So user ID, video ID, then watch time, completion percentage, and timestamp. Okay, so why we need this? Core input for recommendation, detect binge behavior, and then similar user identification. So user watched 90% of Narcos, so it's a strong signal, okay, everybody will like it. Now user interaction table. So now for user interaction table, so user ID, video ID, and then action type, whether he has clicked on it, like it or dislike it, okay, and timestamp. So why we need it? So capture explicit feedback of the video, okay, and then improve ranking accuracy and handle dislike filtering. Dislike filtering means we will remove that from user's recommendation list because he has disliked that kind of thing, right? So fifth one is trending video table, okay. So trending video is as name suggests, video ID, region, trend score, and updated ad. So the videos, all the trend store we will add there, okay. Now show trending, why we needed to show trending now, and cold start solution, and new user recommendation. See, if user is new, okay, what we will show him on his recommendation? We will show him the trending one, right? So now user feature table. The sixth one is user feature table, where we will store the user feature. So like user ID, what is his favorite genre, okay, and then average watch time, binge score, and last active time. Why we need it? So pre-computed ML feature. Next time when he will come, we will show him according to that, and then faster ranking, low latency. Instead of calculating each time, we store them. Seventh one is candidate table. So it will store the candidate information: user ID, video ID, candidate score, and then generated ad. Okay, so store pre-generated candidate, faster homepage load, and reduce ML computation. Again and again, he don't need to calculate it, right? So one time only. Then video similarity table. So one video is there, second video is there. So how much similar they are? Okay, video ID, similar video ID, and similarity score. Because you watch this, so you can watch this one also. That kind of thing. So real-time flow using tables, okay. So what will be the real-time flow? See, user watch Narcos, okay. So step by step, so this Narcos, okay, user watch the Narcos series, and then insert into user watch history. That will go, one entry will go into user watch history table. Then update user feature, okay. So user feature will also get updated with this entry. Fetch similar videos, video similarity, generate candidate. So he will generate the candidate that or similar candidates and then rank them, and then will return top 20. So that's it. Very simple flow. Now cold start handling, as I told you that new user, so we will use the trending videos and we will use the region based filtering. In that region, what was the trending? Okay. Now feedback loop, if you talk about, so user watch some let's say some video. Okay. So now so we will store that in history. Okay, update feature and retrain model better recommendation again for the next time. So that's why also we will add that. So this is the feedback loop, how we will retrain our model. Now metrics, if you talk about, so click through rate, CTR, okay, we will track. Now watch time also we will track, and then completion rate, retention, and then engagement. So we'll track all these scores for this, and then we'll decide on top of that. So final summary, so we have these many tables, okay, like user table we are using to identify user, video table for the metadata, user watch history for user behavior tracking, okay, user interaction, explicit feedback, trending videos, cold start, okay, for cold start we use that, user feature table for ML feature, recommendation candidate for caching, and video similarity for similar contents. So Netflix recommendation system uses user behavior, video metadata, and ML ranking models to store across multiple tables to generate personalized recommendation in the real time. So that's it. Thank you.